fittings down the corridor, all designed for 1.5. On a heavy industrial inductive load circuit, you up the size of the cable, don't you? So the whole corridor is widened 2.5mm cable. So they were putting connector blocks in and a bit of 1.5 to drop it down because of the fact they couldn't get it in the terminals. Fun and games of old fittings and old wiring. New fittings and old wiring even.
Just 1.25 singles or 2.5, is it?
2.5 singles.
You can just take a couple of strands off it, couldn't you? It'll take a while.
For the side. Okay. Any questions on lighting? Okay. We've just got to go through a little bit on heating control systems. You will see the two different types, the two most common heating systems, the wiring diagrams. Don't panic. They never expect you to be able to draw one out. Okay. The common question they'll ask you is name two electronic components in a heating control system. Okay. Or two methods of controlling the zones. And that'll be your thermostats and your zone. Okay.
I think you've got a lot here, haven't you? I'm sorry, can I just check something with you?
Yeah.
I know about Oliver, because
Oliver's transferred.
so he's in this group, that's fine. Yeah, but I've got Mr. Singh, Sahil, and I've got Duffy Deaton on the register, but I don't, they're in my group. Sorry, gentlemen. I don't
So
think this,
I've got
yeah. So they're not in here. We haven't got Mr. Singh in here and Duffy in here. No. So I'll mark them as absent then, because they're obviously not here. No. So I just wanted to check that they weren't in here, and because they're not in there.
I thought I saw Jara on my list earlier.
Yeah. Well, I'll get Jimmy transferred across.
Yep.
So they're in the same group here, which will be good because that will put a little bit of number in here, and because that one's a bigger group.
Yeah.
These two, what I'll do is I'll just email them, so I haven't seen you for a while.
Yeah, because they're on your register for that week, aren't they?
Yeah, yeah, okay. No problem, man. Thank you, gentlemen. Bye.
Okay. So just to run through, so what's this lovely device on this board? It's a thermostat, isn't it? Okay. What does the thermostat do for us? Right. So movable dial normally contains a bimetallic strip. Okay. It'll have different temperature coefficients about coming on and off. Okay. And makes and breaks contact with the change of the temperature because that bimetallic strip, as the room cools down, it bends into a different position to either make or break contact depending where we've turned the dial to. Okay. It sends a control signal to the heating system to tell it to come on or turn off. Okay. Any questions about that?
Is it the same as a light switch, the circuit?
Basically, yeah.
Yeah.
It's just temperature control.
Just on and off, that's it.
That's it. That's all these switches do. It's on or off. Okay. A cylinder stat. Bit of an old technology, this one. Still getting it in some places. What does a cylinder stat do? Yeah, it tells it when the water in the cylinder is cold. So a cylinder stat is actually mounted on the outside of the cylinder. Okay. So it's got to have direct physical contact to the copper or whatever the cylinder is made of. Okay. And it's a thermostat to sense the temperature of the water inside the tank. We can adjust it by the dial that's sitting on the front of it to whatever temperature we want that water to be set to. Okay. What should hot water be set to?
55?
65? 40? 60. Okay, it comes from Legionella. The ideal temperature set it to is actually 60 degrees, which is fucking hot. Okay. Signal sent to the heating system to tell it to turn the heating element on. Okay. We also have what's called an immersion stat. How many of you seen one of these?
Yep.
Okay. So the way this one sits is where you've got your actual heating element. Okay. There are on some of them, rather than a cylinder stat, they have an immersion stat. So there's a small copper tube that runs into the tank, and this slots straight into that. Okay? And the way it's wired is you bring your live to this, and the live from this side will then go to the actual heating element. And that's how it tells it to bring the hot water on or not. Okay? And when these fail, all you do is you undo the two wires, and this just pulls straight out because of the fact that that pipe that it goes into doesn't physically make contact with water. Okay? And you can see that it's got a temperature control already set. Sometimes you'll find that there might even be a thermal reset on there as well. A little button that you just press. Okay? So it just monitors the temperature of the water. It's an info rod, which means it just goes in, it doesn't make contact with water. It expands at different rates to pick up the temperature control. Temperature can be set by the dial. Okay. Okay, water temperature must be set to sufficient if stored to kill Legionella. Have any of you heard of Legionella before?
Yeah.
Okay. Legionella, it exists in all forms of water. Okay. So in this bowl there will be Legionella. Okay. But it's not harmful unless it's at high levels, and if it's airborne, so that you can breathe it in. Okay. So limescale, things like that are actually great breeding grounds for Legionella. You leave your water in your pipe for more than a week, it can start to breed in there. Okay, which is why they recommend that any little used taps in the building should always be run at least once a week. Okay. Cold water should be at about 16 degrees. If it rises above that, it starts getting to an ideal breeding ground for it. There's not much they can do to kill it off, which is why it exists in all forms. Unless you go to some of the highest tourist hotspots in the world, where they say they don't actually have any Legionella in any water anywhere. Okay? It's because the government say they don't have it because they want to keep their tourism high. Okay? Programmers. Okay? How many of you guys got one of these at home? Okay? So what do these programmers do for us? You get smart ones nowadays more than anything. So they can tell your heating system to come on and off. They can tell your water to come on and off. They can also sometimes have a built-in thermostat as well, because I've got the Hive one, so mine's built into that. Okay.
You can have wireless ones, so you can have it around your house.
Yep, wireless. Okay. It's something to look into nowadays, because what's happening in 2025?
No new houses allows people to build with gas boilers.
Correct. So no more gas in new builds. And what's going to happen in 2035?
Start building them again because the heat source pumps are useless. Probably still will be.
In 2035, they're actually phasing out the maintenance of old boilers. So if you have an old boiler, they will not be allowed to install a new gas boiler in any property after 2035.
And who's going to pay for that?
Well, that's why they've come out with a great idea this year when they announced the 2035 of they're going to pay people to get a ground source heat pump or an air source heat pump installed in their homes.
Fantasy world.
Yep. Because when you look at the money they're offering compared to the cost of an air source heat pump system, it doesn't equate. Okay? And personally, with the way the summers are going, I'm thinking more of an air conditioning unit for my house. Okay? So, we know what these controllers do, don't we? Okay? So, we can use circulator pumps, okay? They have 3 speed settings on them, okay? They normally draw 1 to 2 amps. That's all these little heating motors, okay? We also have central heating valves. These could be zone valves, so you could have a room with a valve on it to say that that room will only come on if the thermostat in that room comes on. So if you're dealing with big properties, each room might have a valve on it, okay? We also use the valves on S-plan and Y-plan heating systems to bring on either the hot water or bring on the heating system, okay? The one on the left is a, I'm trying to think what the valve is. It's a 2-port valve, and the one on the right is a 3-port valve. The way the 3-port valve works, okay, is we bring in hot water up to there. There is a ball that moves in the middle of this valve. If the ball sits in the middle, it will provide both hot and heating water, okay? If it moves to one side, it can be used just to provide heating. If it moves to the other, it can be used to provide just hot water, okay? And that's how the 3-port valve works. And that leads us on to the next bit, where the S and Y plan heating systems, okay? Now, I know some of you are thinking of doing like the AM2. You will end up having to wire an S-Plan Plus heating system. The reality is that with anything like this, they don't expect you to know it off the top of your head. Even in the AM2, they give you the wiring diagram for a reason. Because they're complicated systems that can easily be wired wrong. They're not there to cause you to fail, so they actually give you the wiring diagram. Okay? So with the wired plan system, this just has the one valve. Okay? That one valve, if you remember what I said, it brings the hot water in, and it's got that ball that moves left and right, or sits in the middle to allow for the hot water and heating to be called on when needed. Okay, does that make sense? Okay. The most common type of heating system that we have is the S-Plan, where we have the 2 small one-way valves. Okay? One valve will control the heating system, and one valve will control the hot water system. This is the more common system that we have in the homes. Okay? Any questions on these?
What size cables do you run these in?
The cables to the valves are normally 0.75 mil because they're not very powerful. The whole system can actually be run off a 3-amp fuse. So you are running anything from 0.75 to a 1 mil cable for a heating system.
Doesn't tend to have its own circuit in a house, does it? So does it come off
Shower.
It
ring? Does it?
not off the shower, no. It should
Right.
come off the ring or its own circuit because it's only 3 amps. Okay. Showers, you don't want to mix with them because the showers, when they're on, they're drawing 9 kilowatts. So they need all the power. The second you've got that drawing 9 kilowatts plus another 300, you could overload the breaker. Okay. So the most common thing you find is they're normally pulling off on a fuse spur off the ring circuit. Okay. But they are literally 3-amp circuits because the pump is only working at 1 or 2 amps at most. Most commonly, they're only working on 1 amp. Okay. The programmers, right? They're using very little. They're electronics, aren't they? Electronic gear doesn't need much in the way of power to operate. So you're looking at the milliamps for that to operate. The room thermostat, there's no power requirement there at all. It's bimetallic. It's a switch.
You can get wireless ones, I think.
Yep, wireless ones are battery powered. Even less power being used on the circuit. And all you've got then is you'll have a receiver and emitter wired into this system. Okay? And that receiver and emitter still only uses less than half an amp. Okay?
Resistant flex cable, yeah.
Always. Well, anywhere where the boiler is has to be the heat resistance. So if you've got between the wiring centre and the programmers out in the hallway, there you could use 2.5 or a multi-core cable. But anywhere where you're near to that boiler, that is where you must have the heat reflex. Okay, because it's about the environment and the damage on the cable. Okay. Any questions on these heat systems?
So this is a job for an electrician, not a plumber.
Grey area. Some plumbers are actually, well, more gas engineers. They're actually quite competent in doing it.
There's a gas engineer who knows how to do it, but we ended up doing because the gas engineer thought, let's let the electrician do it instead of the gas engineer do it.
Who signs it off? Can a gas engineer sign it off?
Yes, under gas safe, the gas engineers are allowed to work on the boiler circuit and the shower circuit.
But they need Part P approved, don't they?
Their Part P approval comes through gas safe.
Oh, okay.
So through gas safe or blue flame, they actually have approval to work on this one circuit. So if it's coming off the ring, they can only certify from the fuse spur out. So that's where it comes into us. We have to install the circuit to the fuse spur. A lot of companies, because the gas engineers are quite shoddy and shit, okay, so the gas engineers, great.
Too low for that.
I'll show you a picture in a second of my mate's house that had a gas engineer do the work. Some of their work is absolutely atrocious because they don't get much training in wiring at all.